Okay, time to start again. We have Simon Josefsson from Yubico in Sweden here. And Yubico is the creator of the Yubico. Looks like this, and to me it's a keyboard. And I leave it to Simon to explain the rest of it. I got one of these at home, and should we say it could be a secure alternative to RSI security? Yeah, there's one more.
Poll the audience? Anyone else? No?
Yeah, okay, so you had many people to convince that and so on. So, stage is yours.
Okay, thank you. Hello, everyone. So, I'm Simon Josefsson from Yubico. Just briefly about me, I'm a long-time free software hacker working for several GNU projects and other free software projects, and also active in IETF for standardization issues. I work for Yubico right now. So briefly about Yubico, I'll skip most of the sales stuff because we're a technical crowd, so focus on the details. But we started in 2007 and relatively small company. The key invention is the Yubico. So as you can imagine, this is a one-factor authentication device. It's a hardware dongle, and we have lots of customers. So this is what I'll be talking about for the first part, and the second part is our new invention, a thicker Yubico. It's a UBHSM. So it's if this is the key to something, this is the lock to put it in, figuratively speaking. I'll come back to the UBHSM later. I'll go over the Yubico first. So there was two people here who had a Yubico. How many have heard of Yubico? Okay, so it's a couple. How many have used some kind of hardware authentication device like Vasco or Secure ID or anything? Yeah, a lot. Okay, but back to the Yubico. So this is a device that generates one-time passwords, and it has an identification part and an authentication part. I'll come back to later what it means. But so it's no batteries, no display or mechanical buttons, so it doesn't break when used in the sent by postal mail or something like that. So typical usage is replacing the password login prompt with something like this, or combining a password prompt with a second factor. And this is what it generates. So it's an identity part that's static on all invocations, and there is a variable part that's different every time. So just a quick demo. So this, I insert this into a spare USB port and just launch a text editor. I touch the button, it simulates a USB keyboard, so it simulates sending the C, and so on. So this is why it works on practically all platforms that supports USB keyboards. So if I press again, the first part will be static, it's the same. The second part varies. So that's to simply know how it works. So these characters are encoded in mod hex because keyboards doesn't return A or B, it generates scan codes, and these are translated into A and B by the computer. And this was a problem for us in the beginning because there are a bunch of keyboard layouts that are different. So you have to find some characters that are mapped from scan codes to characters the same on all keyboards. This is not essential to understand this, but it's the background on why the string looks the way it does. So we had to find 60 characters that are unique, and we are mapping them to normal hexadecimal alphabet. So, yeah, so string 00 is CC mod hex, and we call it mod hex because it's essentially a hexadecimal but with a different alphabet. So the Yubico OTP consists of the first part is actually a variable, 0 to 16 characters, but we ship them with 12 characters and have standardized on that. So this is the blue part here, and the varying part is actually a AS encrypted part. I'll come back to that later. So having a variable identity part can cause problems, because if you're in lots of situations like SSO login or Windows login, you're entering a password and then generating a one-time passcode. And then if the pass OTP one-time password varies in length, it's difficult to know where the password ends and the one-time password begins. There's a silly problem, but it causes a lot of issues in deployment. So we are standardizing on 12 characters here and 20 here. So what's in the one-time password? These are the internal fields which are then encrypted using AES in standard ECB. How many are familiar with AES? Yeah, security savvy people. But the YubiKey works by generating a plain text block. It's just one AES block, and it's consisting of an internal identity, which is just like a serial number. It has a session counter to make the one-time passwords unique every time, and it's encrypted. And it has some timers. These are incrementing when the YubiKey is inserted into the PC. And there's another counter, it's an unpredictable data, and a CRC. And note well, the CRC is not used for anything security critical, it's just a checksum. So sometimes a problem comes up, but people say CRC system is not secure, but it's not used in a security sensitive way. And once the YubiKey has compiled this block, it's encrypted using AES in ECB mode. And so there's a unique AES key in every one of these devices, and you can program it yourself, so you don't have to trust us to protect the AES keys, unlike some other companies.
Squeaky.
So these counters are used for there is a event-based counter part, which is implemented every time you touch the button, basically. It's for implementation reason, it's divided into two parts. One that's non-volatile, that's just incremented on first use when you're inserting it. Because non-volatile memory is, you don't want to write to it a lot of times. So. And another counter that's incremented during that power up cycle, and that goes away when it's disconnected. The timing information is there to be able to see if you are generating a one-time password at now and in 5 minutes. The server can see that, compare these two one-time passwords and see that these were generated with 5 minutes interval. And that's useful to be able to identify phishing attacks or something like that. Someone stole your OTP. But it's not real-time clock, so you can't say that the user inserted it at 12 o'clock today and pressed it, but you can measure the interval between, and in practice that's sufficient to detect most attacks. So I'll talk briefly this device is configurable, so you can configure it in a static mode, and then it generates the same password every time you touch it. And of course that's quite silly, because then you're back to normal username password problems. With keyloggers and it's even worse, because you only have one physical device and you're likely to use that static password on many different sites, which is bad practice. But turns out that this is very useful for demos and for user acceptance testing. So you can configure 50 of these in static mode, give it to user who doesn't understand this, and just to see how they react. Is it possible to use it? Sometimes department or companies want to do a pre-study to understand if it's going to work or not. And then you don't have to change anything on the server, you're still using passwords essentially, but you can see how users behave and act. And we also support OAuth. How many are familiar with OAuth, HOTP? Not so many. So briefly, this is a standardized way to do one-time passwords. It's based on HMAC SHA-1, and essentially just HMAC SHA-1's a counter every time, and that's generating. So an OTP on this scheme looks like this. This is similar to a lot of online banks are using, perhaps not HOTP, but similar algorithms. And this is open standard, so anyone can read it and implement it. So we support this since, well, yeah, 2009 is quite a long time now. And recently we also support challenge response, so you can send something into this and get something signed out of it, because that's often seen as a weakness, because this device doesn't sign anything coming from the server, it's just sending something to the server. But this challenge response mode requires drivers on the PC, and we are not really, we have added this feature, but we are not pushing it strongly, because we are feeling that this is if you're not happy enough with the security provided by this, you might have a too strong security need, and then you might want to go look for alternatives like certificates or smart cards or something else, because the focus here is just to do simplicity and do that well. And there is a niche there that we believe we aren't met today, because a lot of solutions are focusing on solving just the most highest security solutions like smart cards, but then you end up with smart card driver problems. But we've added this so people can experiment with it, and some people are using disk encryption like this, because then they can unlock their disk encryption using a hardware dongle. So it might be some uses for it. We also combine it with RFID to combine it with physical. I won't go into logistics a lot, but we have automated the process to manufacture this in large quantities quickly. So Yubico provides a whole range of things around the Yubico. Of course, we sell the Yubico in different variants. We also provide software, variants, several variants of software. First, to talk to the device, then also to use it. And we have set up an online validation service. You can validate the OTP against our servers. I'll come back to some examples later. Also have some forum and support. So I mentioned that you can program this device yourself, and we have personalization software. We have a written in C, it's a free software project on Google Code. Well, Actually, it's hosted on GitHub now. We're kind of moving it. And we also have Windows software for people who like Windows, and actually Mac as well. So, and then you can configure it in static mode, HOTP mode, or normal YubiKey mode, and set your own AS key and so on. So, of course, if everyone can reprogram this, it's a problem if someone installs a Trojan on your device and just reprograms it with some AS key known by some attacker. So normally you would program it and then set a lock code, and then it's locked. You need to provide the lock code again if you're reprogramming it. And because reprogramming a YubiKey in normal deployments is so difficult, just to have 1,000 employees coming in with their YubiKeys and to reprogram it's quite costly. So we are recommending just set a random password and discard the password, the lock code, because it's easier to well, of course we like to, it's easier to just buy more YubiKeys and send them out than to bring them in. But yeah, of course, it's an option. But in practice, it's very difficult to manage sending back things and sending them out to the right person again. So looking at some software packages, we have packages that parses these one-time passwords written in C. Yeah, you see some are C programmers who recognize some prototypes. I plan a demo, but I think I skipped that and focus on the UBHSM. It's not very interesting. You can try this if you're really interested, because it's just a matter of reprogramming it. Or just ask me later if you're curious. So I mentioned this is a key. It needs to go somewhere. It's useless to have a key without having it unlocking something. So we are providing a validation server that can be used to build this. So we have a validation server where you can send in these OTPs and get a yes/no answer. So basically Yubico says that, okay, this is an OTP that's valid right now, and then you can build some application that does some authentication or authorization based on that. And Yubico is not managing passwords or anything like that. We are, of course, if you send in same OTP, you will get the response no, and it says replied OTP. We have different kind of error codes, and it's accessible over HTTPS, or we have a CRUD ad hoc scheme to do a HMAC SHA-1 sign of the request. It's simplest used HTTPS, then it's a standard protocol. So this requires client identity and key, and you can generate it from my pages. So let's try a demo. I don't have an internet connection. Not sure if this is possible, but you can go to this site, just yubico.com/demo, and then as a prompt, and you insert the device, generate a code, and hopefully this page will show where it's just congratulations, you're logged in, and it will show the response from the validation server. So, of course,
the timestamp, that comes from the host computer, right? Or
no, this timestamp actually comes from the server, our server in this case.
So it's not a problem if the computer you have locally have their own time?
No, it doesn't really matter, because it's not part of any.
It's not part of any of the key.
No.
Okay. Good.
But normally, when you're designing something, our server, of course, runs NTP and all the time, and your application server has the same requirements. But that's all on the server side. So
yeah, good.
So that's usually not a problem. If you are a command line kind of person, you can just use VJet to access our web service API. And here we are validating the same OTP 3 times. So first time we get an OK and with some hash response, and then we get a reply that the regular OTP, yeah, same again. So this is what we are providing to allow you to build something, to build the lock. And we have improved the validation protocol with some replication and distribute, so it's not particularly interesting. We have a lot of different clients in many languages, C, PHP, Java, .NET, almost anything, Ruby, whatever. So the server-side software that we are using or used to use are free software. We are now migrating to the UBHSM-based solution, which that's also free software, but this is the old software running. So it's divided into two parts. It's a validation server that's responsible for doing the saying yes or no. And there's a key storage module that's responsible for storing the AES keys and just responding, taking one OTP and responding with the decrypted part, because that's very easy to distribute, because the AES keys can be found on several places, and it's also important to secure them. So you want to really lock down the security of where you're holding the AES keys. So that's available. This key might help to understand how it works. We have a few servers that's holding the AES keys, and since there is no synchronization between these machines, it's possible for the validation server, because the validation server needs to decrypt the OTP in order to validate it. So each validation server can, in parallel, query all our KSMs to do a decrypt. And this will take the first response that comes back and use that for validating the OTP. And your client, your application, like I don't know, a WordPress blog or a bank, online bank, or internal web system, will access our validation API. Or you can set up this in your own environment and access your servers. I should mention several of our customers are writing their own backends, because they have, for example, some are very deep into Java and have their own Java environment already deployed. So it's easier for them to re-implement this in Java than to try to make our system work in their environment. And all of everything that you need to do to re-implement it is public, so it's just a matter of implementing. And you can do this in 100 lines of code. So it's not very complicated really. So this was the scalability that I mentioned. The client queries several validation servers to deal with network outages, and these in turn talk to the KSMs. And they synchronize the OTP counters between them. So we have also have some online PHP forum for discussion and a wiki. If you want to raise questions or share with someone else something you've done with the wiki. So we also, how many are familiar with PAM? So essentially it's a plugin architecture for doing authentication in mostly Unix system, but it works on Windows as well. And we have a PAM module for this, so you can use it for logging to your PC or configure SSH for remote login, or anything that where PAM is used, like radio servers, VPNs, or yeah, PAM is quite well used. Of course, we like to see the YubiKey used everywhere, so we're supporting all kinds of authentication identity protocols. And OpenID was something that appealed to us a couple of years ago. It is kind of faded, but it's still quite used. And we did our own OpenID server. That's just one factor. So you can have a OpenID URL which is asserted by one YubiKey. And that's free software that we publish as well. So some are setting up their own OpenID server to be able to log into sites. Maybe I should ask, how many have heard about the OpenID? So that's our server. I won't deal with that. We also support SAML, which is a long way coming. It's, I don't know when it started, around 2000 or something like that, but it's more industry response to federated authentication. There's a bunch of implementations of it as well, and people have integrated support for YubiKey as well in them. So Simple SAML PHP is a Norwegian project, and I like the design of it, so we are using that. But some people have done some integrated into OpenSSO, and we are now using Shibboleth to integrate YubiKey support as well. This is just examples of where YubiKey can be used. So, any questions on the YubiKey before I begin with the YubiHSM? Yeah.
Because before, when I looked at the YubiKey, what wasn't really clear is that you get a key and you can programming with an AES key.
Yeah.
And then you also have free software that allows you to manage this, to set up a framework for identity management, so that you can have the key and match it, the encryption key, and you can match it to an ID.
Yeah.
Is that ID? Is that part of the? The information you get out of the key of the YubiKey when you press the button, does that have a sort of serial number? That,
yeah.
How does that?
Yeah.
Technical part.
Yeah. So I should mention, of course, there is a physical name of every YubiKey. That's a serial number. That's available in firmware. That you can't modify that, but that's not part of the one-time password. You can modify the public prefix. And of course, it's useful to somehow relate the serial number with the public prefix, just for administrative reason. But there's no, you don't have to do it that way if you don't want to. So you're free to modify the first part. And some customers are actually they have reserved part of the prefix for their own use, and they are deploying YubiKeys within that public prefix.
So the fixed part is not the user ID that you type in, is this correct? Or
Yeah. So normally,
it's a username and password. The fixed part is not the one that goes into username.
no, normally not.
So you would have to type that by hand, or how does it work?
Yeah, it can be used in two ways. The normal way is that you have a standard username prompt, and user types Jan or Alice or whatever. And then in the password prompt, they type their password and generate a one-time password code at the end, and it presses enter, submits the field. So, and of course that's a bit annoying because this provides identity, so the user doesn't have to type in Alice in theory. But often you come to a situation or existing pages where you have two windows, and then it's easier to do it like that. But
So is it possible to embed something like a tab or an enter in the fixed part?
yeah, you can program this to actually output the identity part in a tab and then the one-time password, if you want. And that's actually was the default configuration initially, because we thought it would be the natural solution, but we later found out it doesn't work in many different environments like Windows login or SSH, where tab doesn't mean anything. So now we are just combining it one long string. But I should mention, if you're designing a new web application, you can just have one field, and the user provides either just the one-time password or types a password plus the one-time password. And then the user doesn't have to input her username. And that users find that very nice, because it saves them time. And I mean, we all know the problems of remembering passwords, but it's a common user problem to record the usernames, and they don't really know what username they have in all situations.
So do I understand correctly that if you use this with several verifiers, you have to have a different YubiKey for every verifier?
It depends. I mean, if you're going to our validation server, you don't have to. The important part is that you only have one central place that validates all one-time passwords coming from one YubiKey, because otherwise there's a replay attack. If someone gets a one-time password from one system, they can replay it to another. But if you're building web applications, you can use tens or hundreds of different sites all going to our server for validating a YubiKey. So that's not a problem. But if you're building your own infrastructure, then you have that problem. You can't use it against our system and your at the same time. So, because the one-time passwords in here needs to be synchronized with the component that's validating it.
Well, let's say that my bank buys the YubiKey and my university also buys the YubiKey and so on.
Yeah.
I have to have a different one for each of them, right?
It depends on how friendly they want to act. Some customers like to do everything their own, set up their own servers. Then it's not possible for their employees to use the YubiKey elsewhere. But some more open organizations like university are using it against our server. So students can use YubiKey for internal login to the IT system at the university, but they can also use it to log into our forum sites or lastpass.com or any sites using the YubiKey. So the organization buying the YubiKey really decides. And of course, we like for the YubiKey to be as useful as possible, so you don't have to carry around a bunch of them. Well, of course, we like that too, but we realize that users will find that annoying. And that's why we're trying to help OpenID SAML, because that can aggregate this on a different level. Let's say bank buys these, they want to run all their infrastructure themselves, but maybe they can set up a SAML server and an OpenID server to allow their users to use the YubiKey against some other sites.
Are there any plans to switch it to Bluetooth instead of USB?
Yeah, we have that request a couple of times, but the problem is there is no battery in here.
Yeah, I see.
So we have thought about different ways, but the battery is not the only problem. The Bluetooth pairing process is quite cumbersome, and we really like this to be simple. And as soon as Bluetooth and pairing is involved, it doesn't work well in practice at all.
Not if you move between different computers.
Yeah.
Well, and the security of Bluetooth, even with encryption, is really appalling.
Yep.
Yeah. So it's possible to do, and we have prototypes of it. But we if you're buying 10,000 of it will make it, but we haven't seen these kind of requests so far. So yeah. Okay.
So, more questions?
One question.
Yeah.
On the communication between the YubiKey and the server, on the answer there was something which looked like base 64.
Yeah.
It was H, I guess.
Yeah, so.
Can you tell what's inside?
Yeah, so, well, here you see the request, and that's the OTP. This is just the age equals, and that's just a signature on this response from the server. So the client specifies identity when it talks to the server, and the server knows the shared secret for that client ID, and then it signs the response with that. Initially it was just a way to avoid the need for HTTPS and do this over HTTP, but it's not. I wouldn't recommend relying on this. It's
Okay. But this could the answer be forged?
well, if you're using HTTPS, then you're depending on HTTPS and certificate validation, and then you're into that separate problem, but it's a welcome problem. But otherwise, if you don't want to use HTTPS, and some people dislike it and prefer our HMAC variant, then you can verify the response by using the HMAC key. So when you're registering for a key, this is either one, but when you're registering, maybe you get 5,500 or something. Then you have a HMAC SHA-1 key that you can use to verify the responses. So it's a cheap way to get some improved security, but yeah. So I was planning some questions at the end as well, so I'll run through the UBHSM part and then also questions. So, as you have seen, the problem with securing the server side is something that prompted us to do this UBHSM. So what is the UBHSM? It's a I have it here. We are beta testing this right now, and this is essentially how many are familiar with the HSMs in general? So HSM stands for Hardware Security Module, something like that, and it's normally used to store encryption keys outside of a PC because you're not trusting the PC enough to protect the encryption keys. So you put the AES keys in some physical machine, and you have a tight interface between the PC and the HSM. So that's traditional HSM, and there are a bunch of them on the market, and they cost a lot, and then they cost every year as well, so they are quite expensive. And we were considering this for our servers because we want to improve the security on there, so we don't end up, someone attacking us and stealing our AES keys. So we were exploring what's on the market, and we didn't find anything that's really suitable. So we came up with this. And right now it does AES encryption, decryption, and decryption compare. I'll come back to what that operation really is. That's HMAC SHA-1. And it also has a random number generating based on one of NIST's designs. There's a bunch of different deterministic random number generator, and it's a matter of choosing which of them to use. But the DRBG is one of the few nice ones, in my opinion. So this device is able to store 40 keys, has a fairly small interface. So you can see, what is it? It's HMAC SHA-1 generate randomness, ECB block encrypting clips, and so on. And these are the operations you can do with a UBHSM on the key. And the intention is that you can't read out the key from this once it's configured. And we have Python, soon Java code. It's completely documented. So the background was really that we wanted to improve our own security. Yeah, I think I'll get over this. Yeah, I mentioned that the traditional HSM are quite expensive, but another problem is that they don't really do. They just do encrypt, decrypt. They can't take a Yubico OTP, decrypt the OTP and verify it. And we really wanted that because if some attacker gets root on your host, and even if the AS keys are in HSM, they can just pipe whatever on the disk through the HSM and get out the clear text AS keys anyway. So we weren't feeling very protected by having a HSM. Yeah, so we really wanted a model where someone who would get root on our machine still wouldn't be able to do anything. And I think we've succeeded or achieved this to a fair degree. We can publish all data stored on the PC for everyone to see, and you still couldn't do anything with it unless you have access to the hardware, the UBHM, HSM protecting it. So the indirect mode that we're using, because this device only stores 4 keys, so we have to have some way to support millions of AS keys. And the way we're doing is that we are key wrapping the AS keys in one key that's stored here. We're using one of the AEAD cipher modes for the ASCCM for that. How many are familiar with authenticated encryption modes in general? Not many, but it's a new way of encrypting that's also authenticating the data, and it has some nice cryptographic properties. So we're using this to store these AAD encrypted blobs on the server, and then when you get a request, you're sending in the request together with this blob to the UBHSM, decrypts the blob, performs the operation, and returns the result. So and we want something that provides integrity and not just encryption. So a lot of you are probably interested in how you would build a server that validates password for 1 million users without being vulnerable to attacks like Sony or someone else stealing all the information. And one scheme to do this is something like this, that you're hashing or salting the password as soon as you get it. You query some server that has a UBHSM with the passwords encrypted using this AAD scheme, and the server will do a AAD decrypt compare using that blob and the input to the hashed password, and it will return yes, no. And even if an attacker would get root on this machine, they would be able to steal the blobs, but to decrypt them, those blobs, they would need to have the keys stored in here. And our model is that we are not concerned with physical attacks. Some people are, but there is a traditional security industry out there to protect physical stuff, and we kind of let them do that. On our level, we are not concerned, but if someone is able to circumvent the physical security of hosting centers, they are able to do a lot more. So it's a matter of finding the nice threat model or that you're concerned with. So I was over this fairly briefly, but maybe we can come back to this. I mean, we are solving one problem, but we are creating some things to consider. And you really need to manage the keys in these UBHSM more carefully than anything else, because if these keys get lost, then some attacker getting these AAD blocks will be able to decrypt them. But maybe it's easier to protect one key than a million keys. It's helpful. So normally you would have two of these, and you generate the same key in both devices, and use one of them to encrypt these blocks in one place. And that's the server that's responsible for setting passwords. And that's only able to create these AAD blocks. And on the second half, or the second UBHSM, it's only able to decrypt and compare using this key. Okay, that was quite brief, but I think I'll overrun with a minute or so.
Yeah. Any more questions?
Thank you. Any questions?
Okay, well,